vision, that's light waves. Light waves are radiated from or reflected by some object and fall on the sensory surfaces of my body, and that allows me to see. Well, what sensory surfaces? That's the second feature. Each of these sensory modalities, in principle, anyway, is associated with a particular sensory receptor. In the case of vision, that's the rods and cones in the retina of the eye. Light waves falling on rods and cones give rise to the sensation of sight. Light waves falling on my eardrum do not. Okay? So you got to have those two things. Then there's a particular sensory tract, a bundle of nerve fibers that connects each of these sensory receptors to higher neural centers, like in the spinal cord and the brain. In the case of vision, that is the optic nerve, okay? And then finally, there's a sensory projection area somewhere in the brain, typically in the cerebral cortex, that is the final destination for all these sensory impulses, and that, in the case of vision, is the occipital cortex. And the general idea here that Sherrington and others had was that each of the modalities of sensation could be made concrete, could be objectively defined in terms of a package of features like this, each one being associated with a particular proximal stimulus, a particular set of receptor organs, a particular afferent tract or sensory tract, a particular sensory projection area. Miller, a very important early physiological psychologist, in fact, argued that each of these modalities was associated with a particular kind of energy that passed through nerves. This is what's known now as Muller's doctrine of specific nerve energies. Sensation consists in the sensoriums receiving a knowledge of certain qualities of the nerves of sense themselves. Muller's idea was that the optic nerve, for example, carried a different kind of energy than the auditory nerve. And it was this different kind of energy that gave rise to the different modalities of sensation. We know now that that's wrong, okay? He had the right idea, he just didn't put it in the right place. What gives rise to the different modalities of sensation is the occipital cortex. Okay, it's where it goes, not what carries it, and all that. All nerves have the same kind of energy going through them, electrical impulses, essentially. There's really no difference among them. But the general idea that there is some specific biological structure that is responsible for each of the different modalities of sensation is the essence of Miller's that idea, and that's the one that is stuck with us today. Okay, so that's one way in which we can begin to make these different qualities of sensation concrete, get some objective knowledge of them by relating them to various aspects of physiology. Okay, the next way that we do this is by engaging in what the 19th century psychologists called, and still 20th and 21st century psychologists called psychophysics. And in the classic instance, what psychophysics tries to do is to establish various relationships between the physical properties of stimuli and the psychological properties of the experiences to which those stimuli give rise. And again, you can see what the nature of the program is. The experience is inherently subjective and private. But by tying that subjective private experience to something that is publicly observable, that is the physical properties of a stimulus, we try to bring conscious experience under the purview of science. So we've got these first-person subjective mental states being related to third-person the objectivity in terms of physical stimuli, physical energies, anatomical the receptors, and so on. And the 19th century psychophysicists especially argued for what was known as the psychophysical principle, which simply states that every psychological quality of a sensory experience is related to a physical property of the corresponding stimulus. Psychophysics, okay? that there is some kind of relationship there between the physical pattern of the physical qualities of the pattern of stimulus energy radiating from an object and the psychological experience to which it gives rise. And the psychophysicists, Weber, Fechner, and so on, developed a whole host of techniques for studying these psychophysical relations, techniques that are still used in laboratories today. Okay, so like what, for example? A lot of early psychophysics focused on the idea of thresholds. How much energy is needed to give rise to a conscious experience? How much stimulus energy is needed to give rise to a conscious experience? And so they developed a technique like the just noticeable difference. They present a very, very, very dim light to a subject and then increase its intensity very slowly and very gradually until the subject says, I can see the light. Then they turn down the intensity very slowly and gradually until the subject says, I don't see the light anymore. Okay? That's one way in which we can establish the relationship between the physical intensity of a stimulus and whether the person experiences the stimulus at all. The method of constant stimuli, present two stimuli simultaneously and ask the subject if there's a difference between them. The method of adjustment, the experimenter doesn't do the manipulation, the subject does it himself. They're all the same basic idea here, and they're all after the basic kind of problem, which is the problem of thresholds for conscious awareness. Either an absolute threshold or a relative threshold. The absolute threshold meaning the minimum amount of energy that gives rise to a detectable stimulus. Okay? And what that means what that means experimentally is the minimum amount of energy, stimulus energy, that gives rise to a stimulus that can be detected by people 50% of the time. Okay? Or the relative threshold for conscious awareness, which is the minimum amount of change in a stimulus that can be detected by people 50% of the time. And if you think about it for a second, you'll see that the absolute threshold is a special case of the relative threshold, because the absolute threshold is the difference between experiencing something and experiencing nothing. Okay, so these psychophysicists were quite clear about all of this. Kulpe and Titchener, who were early major figures in 19th century psychology, actually tried to establish correlations between the basic dimensions of psychology, the basic dimensions of experience, and the fundamental dimensions of classical physics. For Newton, for Galileo, for everybody up until about Einstein, there were three classical dimensions in physics. Things had mass, things occupied space, and things occurred over time. And the psychophysicists were persuaded that there were parallels to these physical dimensions in the psychological realm. So, for example, the psychological parallel to physical mass is the intensity of the experience. How bright is the light? How loud is the sound? Then they talked about extensity as a psychophysical parallel to space, and that is kind of how much of your attention the thing took up, and then protensity as a psychological parallel to time, how long an experience occurred. And then sometimes they debated about adding some fundamental dimensions like atensity, meaning just how vivid the experience is. Vividness and intensity are not quite the same thing. You can have something that's really not very intense, but still be very vivid. And then finally, the problem of quality. They argued, no, it's not clear that this has an exact parallel in classical physics. So again, what these guys were after were establishing these parallels between the subjective world of conscious experience and the objective world of the physical stimulus. And one way they did that was by looking at the problem of intensity. What's the relationship between the physical intensity of a stimulus and the intensity of the experience to which that stimulus gives rise. In vision, we call that the brightness of a light. In audition, we call that the loudness of the sound. And the general idea is that, yeah, okay, there's some relationship between physical intensity and experienced intensity, and they're worried about how that was coded in the nervous system. There is a problem there. As you'll remember from your introductory psychology course, if you took one, neurons fire on an all or none basis. They either fire or they don't fire. So exactly how do you get gradations of intensity out of a system that either fires or doesn't fire? Well, the answer is it's not just one neuron firing. There are lots of different neurons firing, so that psychological intensity basically is given either by temporal summation, how many times a neuron is firing, how frequently a neuron is firing per unit time, or spatial summation, how many neurons are firing per unit time. But that's basically how the nervous system does it. But it turned out that there's not a one-to-one relationship between physical intensity and psychological intensity. The guy who discovered this first was Weber, gave us Weber's law, delta I over I equals C, which basically means, translated into actual words, is the amount of change necessary to produce a perceived change in a stimulus is a constant fraction of the original intensity. Change in I, change in intensity over I, it equals a constant. So, for example, if the original intensity is 10 and your constant is 1/10, that's known as Weber's fraction, then it will take 1/10 of 10, or 1 unit, additional intensive physical intensity for the subject to be able to perceive that intensity is changed. But if the intensity of the original stimulus is 100 units, it's going to take 10 units of change, not 1 unit of change. And if the intensity of the original stimulus is 20 units, 200 units, it's going to take 20 units of change. Delta I over I equals a C, the amount of change necessary in the physical stimulus to produce a change in the experience is a constant. And Weber's fraction turns out to be, that's Weber's law, Weber's fraction, that C, turns out to be quite nice because it allows you to measure the acuity of various sensory modalities. So here are Weber's representative Weber's fractions for human sensation. Visual brightness of a white light, that Weber's fraction is 1 over 60. Okay, so it takes very little change in intensity to give rise to a change in experience. For weight, it's 1 over 50, so a little bit less acuity. Thermal pain, 1 over 30. Well, you can read these for yourself. The general idea here is that by use of Weber's fraction, you can quantify differences in the acuity or the sensitivity of various sensory modalities. And you can do that across modalities within a species to determine, for example, that vision is somewhat more sensitive than audition. And you can actually do this to quantify sensory acuity across species as well, allowing you to determine that the sense of smell of your dog or your cat is more acute